Okay, for this video I'm gonna explain how to connect the CNY. This is a sensor, is this one. For this type of sensor, as you can see, we have two parts. In this case, the one that is clear is an LED. That means that the LED will be sending a little bit of light to a surface, and the other one, this one, is a transistor. The transistor will be calculating the amount of light that is being reflected from the LED. But the truth is that the LED is not too powerful, so following that, this sensor works really good, but with good light conditions. If we don't have good light conditions, it's not gonna work properly. So for this one, we're gonna need the CNY. We're going to use two different resistors. One for the LED, which is this one, 220 ohms, and one for the transistor, which is this one, is a 10K resistor. So remember, red, brown, 220, and brown, black, orange, which is 10K. As usual, we're gonna use a couple of jumpers. We're gonna use the breadboard, our Arduino, and we're gonna use this, which is like the way to test it. Depending on where the CNY is, it should give me different readings. At the end, the idea is that you should be able to weld everything to have this on a different surface, so you can use it in your own robots. It should look like this when it is welded, following the same diagram that you have on the screen. Okay, so following the diagram, first thing I'm gonna use is the sensor. In this case, I'm leaving the LED on the left, so I can follow the same diagram. Now, first I'm gonna do is to plug this, the resistor. So I'm gonna start with the one of 220, which is the one of the LED. So as you can see, I am going to connect here in red the 5 volts to the Arduino, and here in black the GND of the Arduino. So I'm going to plug this here, and this one goes directly to GND. Then I'm gonna do the same, but with the transistor. So I'm going to plug it here to GND. Now that I plug both of the resistors, plugged, I will have to connect to the positive, to 5 volts. So I'm gonna use these two jumpers. This one is here and it goes to positive, to 5 volts, and this one is here and it goes to positive. And the only thing I'm missing now is the signal. So for the signal, I'm going to use this yellow jumper here. It goes from the transistor. It goes out here, between the transistor and the resistor. So the thing is that if I put this here, I'm gonna make some shadow on the sensor and it's not going to work properly. See, I'm gonna take it out carefully. I'm gonna put it here, and I'm gonna use male-female jumpers so I can move it away. So, keeping an eye on the order, it says that these two, the green and the blue, will have these two. The green and the blue here and here. And it says that is purple and gray. So I'm gonna plug purple here and gray here. So the only thing I did was to move the sensor from the breadboard to somewhere else, because in this way I would be able to put it here to sense whatever I need to sense. So final step, I'm gonna plug my yellow wire to A0 following the diagram, the black one to GND, and the red one to 5 volts. So this is the way we're gonna test our CNY. Okay, and the code is pretty simple. Here where we have to declare, first thing is we're gonna say that this is constant, CNY, that's the name I'm going to assign to the sensor. CNY will be plugged to A0, as we saw in the diagram. And then I have to declare this variable, the name I gave it is color, and the variable color will store the variable of the reflected light. As I told you before, it's an LED that sends a light and then the transistor receives it. So it detects how much light it is receiving back. And based on that, it can determine if it is black or white. So I have to create this variable color to store that information. Then in the void setup, I'm going to declare using the pin mode that my CNY, which is the sensor, is an input, which is a sensor. And then I am going to declare serial begin 9600, which is that we're going to need the serial monitor because there is where we are going to check the reading of the sensor. After that, I have to read the sensor by using analog read CNY, and the reading I'm going to store it in the variable color, which is the one I declared here. So it's analog because it will not give me just two options. It doesn't tell me if it is black or white. No, it will give me back the reading based on the environment. So if we have a lot of light, it can give something like 45, 50, and that means if it is white. And if it is black, since it cannot reflect that much light, it will give me 1 or 0. So we're gonna check that by using an analog read. Then I'm gonna display or show that value is using the serial monitor. I'm going to show the variable color, which is this one, in the serial monitor, and finally I'm gonna wait for half a second. So I'm gonna have readings each half of a second. Remember, this is going to be repeated over and over again, so it will read the sensor, display the information in the serial monitor, and then wait for half of a second, and like that and like that. Okay, now I'm gonna test the CNY. I just plugged the Arduino, as you can see it is on. I'm going to upload here the program before, and the idea is that I'm going to use this to test it. So now that it's done uploading, I'm going to open the serial monitor, and in the serial monitor you can see that here, since it is detecting a lot of light, it is giving me readings of 100 and something, 200, which is a lot of light. But when I put it here on the white surface, it is giving me readings of 34. But when I go to the black one, it says 0 automatically, because the amount of light that is being reflected is 0 according to the sensor. So we can determine that if I go to white, my reading of white is more than 25, let's say, but my reading of black is always 0 or 1. So I can say that any number above 3 or 4 is white, but any number below 3 or less will be black. And this is the way we can sense it. Things to keep in mind: the sensor has to be at a distance of something like 5 millimeters from the paper. If it is on the paper exactly, it will display readings of 0. So you have to give it a little bit of distance. Something between 5 millimeters and 10 millimeters would be perfect for the sensor to work.